We are here to get enlightened by the lightning talks given by 4 speakers, I would say, and 4 different topics on social awareness, I would say, would be taken care of. And the very first presenter that we would be having is Panna Pavangatkar, and she's seated right here across. And so the topic that she's going to talk about is inner source, leveraging open source best practices in the enterprise. She is working at Bloomberg's as a global head of engineering developer experience. She is responsible for engineering software, development platform, architecture office, and engineering training. Her global experience as a technical fellow, vice president at Goldman Sachs, New York, and JP Morgan, Singapore, and NIIT Pune, India, gives her a unique perspective to understand both cultural and gender diversity, and it impacts within the developer and engineering communities. She's going to talk about inner source, where what lessons she learned from the open source software movement and aims to apply them to the way companies develop software internally. This lightning talk will focus on the benefits of inner source, how to get started within a team and within an organization, and more importantly, how to create a culture and movement at the grassroots to benefit not only the enterprise, but especially be beneficial to grow, strengthen, and coach the diverse pipeline internally. So we welcome Panna, and over to you.
Thanks, Anuja, for that introduction. So my name is Panna Pavangatkar, and I head up the developer experience team at Bloomberg. Bloomberg is a financial software, data, and media company. We're in the business of providing information, and our 4,000 developers, or 4,000 plus developers now across predominantly New York and London and Pune, contribute to making one of our core products, which is the Bloomberg Terminal, one of its kind. What I'm going to talk about is, and for those of you who haven't seen the Bloomberg Terminal, I'm going to try and see if this thing will work. So that's just a one visual, but come by to our booth and you can probably see more about what the terminal looks like on some of our financial folks who use the terminal on a daily basis. What I'm going to talk about is inner source. And while the concept is not new, the terminology is. So when I started looking for words to describe what collaborative software development within the enterprise should be called, there was lots of terminologies being thrown around. And when I searched for inner source, because I had heard about inner source, when I searched for it, basically what I found was inner healing, internal meditation, stuff like that. And that got me thinking, and I started, long story short, I started to say, well, we should actually brand inner source much more widely and get it accepted as a much more acceptable terminology to bring in and leverage the best practices from the open source world into the enterprise. And this becomes more and more relevant today because of the fact that the world is changing. We have our developers who are coming in. I don't know how many of you out here are from the millennial crowd, but I grew up at a time when we didn't have, the internet was not so prevalent. Our mobile devices were not that prevalent. You grew up in silos. You contributed in silos, and that's what you knew. But today the world is changing, and when I go recruiting or when I go and work with students in the campus, they're already aware of things like GitHub. They're aware of things like GitLab. It's a normal way of functioning. And when they come into the enterprise, it's very difficult for us to tell them, no, we have security reasons, we have regulatory reasons, we have enterprise reasons that you cannot contribute to another place. So 2 years ago, when I started at Bloomberg, what we decided to do was to create a very conscious awareness around the fact that we want our developer community to be able to be transparent, collaborate, and be able to contribute to not only their projects, but other projects as well, and function very much like they would out in the open source world. So yes, we have our regulatory concerns, yes, we have our security concerns, but at least we can create a culture which is very similar to the open source culture internally. And the focus could be on innovating stuff as opposed to living within our silos. So, these benefits or the advantages of bringing in open source best practices is very well known to the management teams. It's not that they're not aware of it. So our approach was slightly different. And, in my couple of decades that I've been in the industry, I found that there are as many approaches as many companies that exist. So what I want to share with you is how we went about it and how we, embraced the new terminology of inner source, as well as made the grassroots effort to change the way the culture is. So beginning with introducing the concept. Ad nauseum was the word I would use because I talked about it anywhere and everywhere I got the opportunity to create the excitement and the buzz within the developers to say, this is good for all of us. We are going to benefit if we get the ability to have an open code base, be able to leverage things and problems that people have already solved, be able to contribute to others, and of course create a culture where we can mentor and grow other developers and also raise the bar for all of us when we collaborate and work together. And so we had to identify some early adopters. And so what we did was a three-pronged approach, which is basically identified some really easy, low-hanging fruit, some projects that would benefit everybody. So predominantly software infrastructure kind of projects, right? So you have your developer workflow. I have some code that I want to work on. I need some reviews. I want to be able to commit that code. I want to be able to run my tests, put it into continuous integration, get my product out there and deploy it. Very simple workflow. However, what we wanted to do was the tools that are used behind this workflow said, let's open source those tools internally, which is let's open up that code base at least so people can start contributing to it. Some of the tooling absolutely helped us, right? So we adopted Github Enterprise in-house, which meant that you have the opportunity to have your public repositories and your private repositories, be able to encourage more repositories to be public, which is by default, we create our repositories as public. And of course, I got into a lot of trouble with legal and risk and had to talk to them about why it was a good thing. That's a separate story altogether, but be able to say all repositories are open, you can search across the repositories, you can contribute to the repositories. And the pull request, everybody familiar with GitHub? Okay. So the PR model worked really well because it's not like I'm impacting. In the old traditional world, it was that I'm committing code to your code base and now I'm going to break something and things are going to get messed up. Now the PR model works really easily because I can submit a PR and you have your contributing.md has your guidelines. So what we said is you must have a contributing.md. You must put in your guidelines as to how you're going to be able to accept code. So if I've put in a PR, there are very clear specifications on what the PR must include, and then you can review it and accept the PR and merge it in. We also put in things like help wanted labels, and we emphasize that people should, if I don't have time to work on a particular feature requested by a team across another functional team or across an organizational boundary, my repository is open, my code base is open, feel free to contribute to it, and I can put in a help wanted label and help wanted issue, and you can contribute to it. And because of the clear rules of engagement, we can actually move things forward. So this concept of help yourself or self-help became more and more popular, and developers found it really easy to be, move their own agenda forward. And the last approach was, so we've introduced the concept, we've created this low-hanging fruit, we've created some projects, we've created the awareness, we've got some people contributing to it, and last but not the least, creating the awareness through metrics, and I'm going to come back to metrics later. So be able to showcase and shout out successes, be able to say, here's the number of repositories that are getting contributions from across other teams. So being able to share those successes made it easier and more acceptable for people to say, hey, this is a concept that can work, despite the initial, will this work and it's not going to work ever kind of scenario. So what are the challenges? When does the challenges come in? When do the challenges come in? Like any project, initial curve is rapid, You get onto the proof of concept and you move forward, and then suddenly you plateau because you've plucked off all the low-hanging fruit. You no longer have any low-hanging fruit to pluck off. Now comes the real challenges. And when we started looking into what across the companies, what across the enterprises, and I worked with quite a few companies in this room, in your open source offices, to try and see what are the commonalities that raise all these challenges. The 4 dimensions which struck out to me, which we had to overcome, were predominantly your organizational structure, culture, and dynamics. Like, how does your organization really function? Do you work in silos, or do you have teams that go across? The global distribution, that is an increasing reality, and we have to just accept the fact that even our agile teams are not going to be co-located, much as we try. And as the global nature of our workforce increases, it's a reality which we have to deal with. Tooling, developers can be pretty religious. So every developer wants their own tool, and the religion and the dogma around which tools work best for them. Code pride. I say code pride tongue-in-cheek because everybody's inherited code. People have, people are writing new stuff. People are making shortcuts because there was a deadline to meet. Now you're telling me I have to open up this code base and let the guy sitting next to me or the gal sitting next to me throw darts at it because I took a shortcut or I could have written it better. That's why I say it's tongue-in-cheek, because we all want to have pride in the code that we're writing, but we're scared to open it up and get other people to comment on it. So, and that was a common set of challenges that we saw. And as we started to move to that second layer of difficulty of saying, the easy fruit ones have been done, let's dive into what the developers are going through and why this movement, which I started at a grassroots level, is now facing resistance. And what we found was that our organizations were never meant to share. Therefore, we don't have time to review somebody else's code. I don't have time to take into consideration that I want to mentor somebody and coach them on how you should be committing code to this project or what my code quality rules are. The not invented here syndrome, which is I didn't write it, it can't be good, I'm going to be left supporting it, so no, I'm not going to accept your pull request. Higher code quality expectations. When I write code, I write the best stuff, I don't need the test. But if you write code, you better put in the test because I don't trust you. And it's an additional responsibility. So when we started looking at these things and we said it is complicated and it is a cultural thing and we have to figure out how to get developers more comfortable in being able to throw darts at each other. I would invariably take a dartboard and say, all the darts can be thrown here, and when we start working on the code, we stop throwing personal darts. It's about the code base, let's concentrate on that. And really how we went about solving it was very clear. It's not personal. Let's get very, very specific about the roles and responsibilities around who's a reviewer, who's a committer, who are our trusted committers, what kind of contributions we accept, what kind of contributions should we be accepting. So really clear rules of engagement. And the last 2 points were the global and the cultural diverse nature, as well as the coaching and mentoring. I don't know how often I have sat in any of your messaging tools or and I'm an outspoken person, but when I'm actually wanting to say in an instant message or something like that, how do you solve this? Or what was this basic thing that I seem to have forgotten? I know I'm going to have 20 people shout out to me or say that you're an idiot for not knowing this basic thing. And I'm reluctant to ask that question. It's that same thing with code reviews. It is the fear of being critiqued. It's the fear of being judged. And across culturally as well as across diversity, that's a conscious effort that we have to make and engage with everybody. So for instant messaging and other things, I started to speak up and say, you're not allowed to bark, bite, snap. You have to accept and coach and mentor. And we really have to become that way for each other as well as within our organizations to encourage that kind of behavior. The other thing is, as I said, tooling. What we decided was to say that instead of getting caught up with the religion, we would make the tools be likable, so we would make it easier for developers to jump into those tools. Offer up stretch projects. So if they feel that the workflow needed to be changed, get them to contribute to it and leverage this whole inner source concept and get them to build up the workflow to what they wanted it to be, or the tool. A ton of hackathons, and of course, for that buy-in, data-based approach is what my last slide is going to be about, is, again, back to metrics. Numbers speak. And so while we started it as a grassroots level, we actually created a Bloomberg terminal function called sauce, so our senior management could type it out. I won't go into why it's called sauce. But so SAUC is a function which we use internally. All it does is basically scans all our repositories to say where there's a contributing.md. Scans how many forks on that repository, scans how many pull requests, which pull requests are coming from other places, and how many contributions are being made. And we use this scorecard not to shame people, but to encourage people to say, you want to be on this scorecard and get your repository up there. And basically encourage more and more developers to want to open up their code base and get contributions. And with that, I'm out of time, but there's references on the slide, and I'm open for questions after the session. Right. Get in touch with me. My contact details are here, and I can share any information you want.
Thank you, Panna, so much for the talk. So the next speaker is Charulata Varadrajan, and along with her, Srinivasaki Murugesan will be here. The topic is effective thermal management using open source on embedded systems. Charulata is working as a display lead in Intel Technology, India Private Limited. She has an expertise of more than 13 years in the field of embedded systems. That includes majority of her work in Linux device drivers and system integration. She has a good exposure and system to open source Linux kernel. Her past experience includes working as a project associate in IIT Madras and as a design engineer at Texas Instruments. Her current role focuses on the Chromium OS graphics and thermal components for Intel Chromebooks. She is one of the committee members for GSC since last year. We have Srinivasaki Murugesan. She is working at SCL Technologies Limited. She is a skilled hardware design engineer, having an extensive experience in the full life cycle of the product development. Their talk is on effective thermal management using open source on embedded systems. This paper is going to talk about how thermal management is important on design and how to implement it in a reliable manner. So we welcome both of them on stage, and over to you.
I'm going to talk about the heat generated on your handheld devices. So thermal management using open source on embedded systems, using open source by leveraging it. And here we have Srinivasaki Murugesan from HCL. She had contributed towards the PCB layout of her boards, and I'm working on Intel Chromebooks, and I worked on the open source part of the Chromebooks. Let me ask you a question. How many here haven't used any handheld platform? Laptops, mobile phones, tablets? There is none. Yes, very much useful for everyone, and it has become part of our life. Everyone must have seen there is some heat generated whenever you are doing some specific application. Any such application can you come up with? Anyone? That generates heat when you are doing on your mobile phone, smartphones? Games, video games. Hotspot. So that means there is some heat generated on your devices and you are using it with your hands. Let me say you are using a mobile phone for playing your games. The mobile phone is getting heated up. Then there is a call received and you forgot your headphones. What happens? You're going to use it and you're going to take a call, attend it. If there is no control over this heat, what happens is going to be your ears are going to get burnt. Are you interested in buying such a handheld device? Definitely no. So we need to have some kind of thermal control on your device. Today, I'll be talking about what thermal management is. I already spoke about why thermal management is required and how we use it from open source and whether anything else is required to make it better, how to make it reliable. These are some pictures from the internet downloaded. This clearly shows how much it has impacted people's life. One wants to make omelette, their breakfast, using the laptop heat. Another wants to make a popcorn out of the heat generated from the mobile phones. Definitely, this creates such a bad impression about your product on the market. So it is very important to have thermal management on your system designed perfectly, and it has to be a reliable one. So why is heat getting generated? Any idea? Why do we get heat generated when we are driving some application? Moore's law, basically. Moore's law, Intel co-founder Gordon Moore, he says that every 2 years, the number of silicon, number of transistors in a given nanometer doubles, which means your silicon density is increasing. When the silicon density is doubling every 2 years, your power dissipation also increases. If the power dissipation increases, the temperature is going to increase because you are using it so much. And within that space, you have to ensure that the thermal dissipation, everything is happening. If the temperature is increasing, the power is again going to increase due to the leakage power. Again, it is going to increase the power, increase the temperature. It keeps going on and on. Obviously, if there is no control, it is going to affect your system. The goal of the thermal management, what it is, you have to ensure that your device is operating at a safe zone of temperature. If you are taking care of the thermal management, you shouldn't leave your performance. You have to ensure that the user experience is not affected because of thermal management. So how do we implement this? It starts right from the hardware. That's why my friend has contributed to this paper. And hardware, it starts even from the IC design. How you put your IC fabrication, then goes on to the PCB design, then whether you have to have a fan or fanless design, all this matters on thermal management. Later comes the software, but it plays a very vital role. What it is? So the thermal control software can be implemented using open source. There are different ways of doing things. One is ACPA standard. It's an industry specification for power management on handheld devices. We use the thermal component part of it, and you will see that it is being used widely in the Intel platforms. On ARM platforms, you will see something called dynamic thermal power management, thermal management. I'll explain what it is. In ACPA, there will be some thermal zone defined on your platform, and each of them will have multiple sensors or one sensor that will be communicating to a policy manager and informs, okay, this is the thermal temperature now. Based on the temperature, some actions will be taken. In this case, we have active, passive, and critical. These are some commonly used temperature threshold points. If the temperature crosses some active threshold point, then a fan will be switched on. That's why we have given a fan there. The fan speed can be adjusted according to how much temperature control you will have to do. Then, if it goes further beyond that, passive threshold temperature comes. There, you start operating at a slightly lower frequency, or you can reduce the power state of the system, which means the performance is going to be affected, but you will ensure that it is not going to affect the user experience. Third is the critical temperature threshold. If it goes beyond the critical temperature threshold, it means that you have crossed the safe temperature zone. So you immediately shut down the system gracefully. This is what is a total summary of ACPM. And this is what we used on our Intel Chromebook. And DTM. DTM is dynamic thermal management. Here it operates on the principle of power is directly proportional to the voltage and frequency. If you slightly reduce the operating voltage, or if you slightly reduce the frequency of operation, your power is going to reduce. If the power is going to reduce, temperature is going to reduce. So there is a difference between the passive temperature here, passive temperature threshold on the ACPA, and here the dynamic thermal management. What it is? Here it is going to operate based on the load. There it is going to operate based on crossing a temperature point. That is the whole difference here. This is the system stack using open source, and any platform will have a hardware which has SoC and the microcontroller. Microcontroller or the SoC. Some platforms might not have microcontroller, and many of the Intel platforms will have microcontroller. You will have thermal sensors and the controller connected to any of them. Mostly it will be connected through microcontroller if there is a microcontroller design. And fan. Fan is a cooling device. Software cooling devices on the kernel are CPU management or the Intel power state, the P state management. Here you see the user space is there, and user space is the one who has the policies defined in it. the active policy, passive policy, and the critical policy. All these are defined there. And it decides based on the thermal events passed from the kernel, it decides on what to be applied. And then it is passed on through the kernel, and the drivers finally implement it using the microcontroller or using the SOC on your hardware. In our case, if you see, the SOC is the one which has the whole software. The software of kernel, which is version 4.4, and Intel DPTF. That is again an open source technology which can be used across different OSs, different platforms, and it has all the details of how do you use it, how to implement it on your platform, and how you connect it with your interfaces, kernel interface. And kernel will have sysfs interface to connect to the user space, and it has the system drivers that connects to the hardware. Here, user space is the king. He decides what has to be done. And the kernel framework is like a ministry. They will figure out how to execute it, communicating to the king and communicating to the labors. And finally, everything is boiling down to here. So as I said, everything is done. We used kernel version 4.4, and we had the sysfs interfaces, we had the sensor and the fan drivers and everything. Everything is working fine. What else is required? We wanted a BIOS implementation, which is the firmware for our device. For us, on Chromebooks, we have something called core boot. So that was implemented by us. Later, when you are testing, you will know that you will have to have an optimal temperature range. Active policy, passive policy, and critical policy works on temperature threshold. All have to be optimally decided based on a platform. Once these are all done, extensive testing was done. Everything is working fine. Do you think there is any problem in the system? The whole software is using open source except for the BIOS side, and even core boot is open source, and everything is running on the software, SOC. Everything is working fine. All the user scenarios are tested. But we thought, what happens in this case? The king dies. What happens if the user space hangs? It's a possibility. The SOC can continue to run, whereas the user space of thermal management alone could fail. And obviously, the SOC could reach a higher temperature threshold, and the system reliability is gone. How do we handle this? This is some unique situation which we thought about. Then we came up with a solution. As I said, this is about the thermal management app hang. I hope you understand this. So, more reliable solution. What did we do? We added a software stack on the microcontroller, which means a minimal software to run on the microcontroller right from the booting time. It will at least switch on the fan, or it will do a basic control, so that even if SOC is absent, it will ensure that the SOC is going to operate only on this kind of system. And if the thermal management app goes into a failure mode and we are reaching out of the safe temperature zone, the fan will be again switched on to the maximum level using the BIOS, using the microcontroller software stack. This is what we did, and this is one of the Chromebook that I worked, and it is already it is already available in the market, and we can ensure that there will be no temperature problems in this. You might be recalling there are some devices that were recalled from the market due to overheating issues recently. So I can ensure that this is not the case. I urge every system designer to ensure that thermal design is done properly, as it is one of the most critical component in your system. Thank you. And any questions? On the hardware side, you can ask Srinivasuki. She's from HCL, and she works on hardware design. I work on open source display and thermal management on Chromebooks.
I'm going to talk about KLP, Karnataka Learning Partnership. Every child in school and learning well. That's the line for the KLP. So she has been in the software industry for around 12 years, first with IBM around, and now with Karnataka Learning Partnership. In her stint with IBM, she used to build real-time collaboration software. She now devotes her software skills to help improve public education in Karnataka. She is also the author of a book called R2I Dreams, for here or to go, detailing the dilemmas of immigrants yearning to return to their homeland. So, Subhashini, over to you.
Thank you, Anuja. Can you guys hear me? Okay, good morning. My name is Subhashini, and I work for the Karnataka Learning Partnership as a software developer. And over the next 10 to 15 minutes, I'm going to talk about how we are using open source to drive change in the public school system of Karnataka, or government schools as we like to call them. This graphic here shows you the DICE report for the Bellary district of Karnataka. DICE stands for District Information System for Education, and it is a comprehensive annual report that's published, and it contains information about the public schools all across India. It gives you information about school infrastructure, enrollment rates, dropout rates, medium of instruction, and everything. This is a public website, dice.in, that everybody can go look up. Now, if you look at the bottom of this graphic, I've highlighted 3 things here: schools with girls' toilet, boys' toilet, and drinking water. The report says that for the year 2014-2015, all the schools in Bellary district of Karnataka, primary and preschools, have 100% toilet facilities and 100% drinking water facilities, right? And the URL for this report is at the bottom of the slide. You can go check it out. The interesting thing about DICE is that it is self-reported data. Each and every school reports the state of their school, and it gets rolled up into this comprehensive report. Now, this slide shows you the crowdsourced data for Bellary. Now, this is from our database, from our website, from the Karnataka Learning Partnerships website. And if you look here, by crowdsourced, we mean that this is data that is gotten from the community, from parents, teachers, students, volunteers, educators. This is each person reporting about their own village school, right? And if you look here, it says, how many schools have toilets for boys and girls? 61%. How many have drinking water facilities? 88%. That is a 39-point difference, my friends. So what is your first reaction when you see this? You go, why? What's going on here? Why is there such a huge difference between what is being reported there in the DICE report, 100%, versus what we see here, right? And this is pretty much the reaction that we get even from our MLAs, MPs, and other decision makers when we show them these reports. They see the same reports as you do, and they go, why? What's going on? And as much as we like to vilify them, I think they are as genuinely surprised, and they ask why. And when you ask the question why, that is the beginning of real progress. That is the start of a revolution, right? So I'm going to talk to you about how we crowdsource this data about schools and how we are building a platform for it, the challenges that we face, and how we have used open source technology to overcome many of those challenges. So before that, let me give you a little bit of context. So one of the things that KLP does is we provide visualization of school data. One of the ways we do it is through the use of maps, right? So this graphic here shows you a Google Maps-like interface, which you can see on our website. It will give you your current location, and it will show you all the preschools and primary schools around you, the little green and purple markers that you see on the screen. And when you click on one of those pinheads, you will see a pop-up like this, which gives you the school name and school information. And when you click on more info, it shows you more information about schools. How many girls, how many boys, does it have a playground, etc., etc. Now, so we've got geographic information, latitude, longitude information of every single primary and preschool in Karnataka, because our volunteers and field staff have traversed the length and breadth of Karnataka and documented this, right? We've also got school information for all the primary and preschools in Karnataka. And there are areas where we have gaps, which we fill in using the DICE data, the annual report that gets published. We fill in the gaps using that data, and we present this visually. So data is at the heart of what we do. Big data is at the heart of what we do at KLP. And when you have this much data, how do you present it? How do you visualize it? And also, how do you keep it current and up to date and valid and accurate? Because like I said, DICE is self-reported data. And as any good statistician will tell you, self-reported data has inherent biases. It is not always accurate. So how do you keep your data current? Because we are a small org, and as much as we like to gather data, there's only so much we can do. So one of the things we decided early on was we needed a way to kind of crowdsource this information and push it down to the grassroots level, so people will be able to contribute information about their village schools to us so that we can keep current. So crowdsourcing was the way to go. And initially we started out doing pen and paper data collection from all the districts. We had volunteers go out and canvass, the community, gather the data, and it would all get translated digitally in our data entry system in office in Dharwad, Karnataka. And then we thought maybe we need to take a step forward with technology and get away from this pen and paper model, eliminate a middleman. So then we said, okay, let's open up a feature on the website called Share Your Story and encourage people to just log in, log in with us and start sharing information about schools. Like this shows, was the school open, was the headmaster present? So we had a questionnaire set up on our website and people could just log in and share their story about a particular school, in this case, school in Ediyur, right? So all of us developers were pretty pumped about it, and we were so happy we were building something, and it was really cool. Spent a lot of weeks building it, and then we threw it open to the public, and guess what happened? Nothing. Nothing happened. We didn't get any traffic. We were pretty bummed about it, and finally, after moping around for a couple of days, we went to our field manager, a really sharp guy called Shankar, who actually does the actual work, whereas we just sit around in the offices. So we went and asked him, hey, Shankar, what happened? Why is it that we are not seeing any feedback, right? And he went, oh, finally you come to me. You should have come to me first, right? So he said, so in the areas of Karnataka that we operate in the remote rural areas, Kushtagi, Mundargi, Koppal, and all these places, people do not have computer or smartphone access. People just haven't heard about them, or they don't have them, they just don't use them. How do you expect them to come and tell you how their school looks like? Limited net access. Even if they do have a computer or a smartphone, they do not have data connection because Airtel doesn't have towers or Aircel doesn't have towers or whatever, right? And thirdly, there is no incentive for people to go off, learn a whole bunch of new things, and then come tell you about their schools. So then we kind of scratched our heads and said, okay, what do we do now? We said, let's do voice. Everybody has a mobile phone in India. People have landlines. So maybe if we opened up an IVRS hotline to people and asked them, hey, tell us about your schools, maybe it'll be a better deal. So we did that. Again, it all feeds back into the same database. All this is built using open source technology, and it feeds back into the same DB. It was just different ways of gathering the data about schools. And this one, we found we had a different set of problems, right? This was a better response than the website. But here we found that people said the questionnaire was too long, and there were call drops all the time. We all know about that, I'm sure. People are at the last question, and then all of a sudden the call drops, and when they dial back in, they have to start from scratch again, and nobody wants to do that. And especially in rural areas, voice calls are still expensive. They may not be for you and me, but it's still way too expensive. So then we decided, let's address this. So we said, maybe we just get them to send an SMS with a question number and a yes or no or I don't know answer, right? So we got them, and we shortened our questionnaire to just basic 5 questions. We said, let's just boil it down to 5, and we get them to answer it. And this was actually a success, much better than the IVRS and website. So we did that. And then finally, as one of the last responses from the community, mobile doesn't feature here yet because it's fairly recent. Finally, I want to leave you guys with one final thought. 23,000 crores is the annual state budget for the government of Karnataka to spend on primary and preschools in Karnataka. We spend 575,000 crores across India for primary and preschools. This is taxpayer money, this is your money and my money that is getting budgeted for our primary and preschools. 13,500 rupees is supposed to be the annual spend per child for a decent primary education in Karnataka, and that is a government number, right? And yet I'm sure that all of us who have kids in private schools are paying 6 to 7 times more on education, and we are also indirectly spending this. This is our money, and it's time we started asking the question, why are we not getting value for our money? Why is our public school system not working as per our expectations? I hope I've given you food for thought, and connect with us. This is our information. I'll be hanging around here if you have any questions as well. klp.org, we have a Twitter handle as well, and a Facebook page, and our website. I hope some of you at least go and visit our website and start asking the question, why? Questions?
Bhashini. And now we would like to welcome our last lightning talk presenter, Snehal Chaitanya. And she is going to talk about impacting lives to devices, force and assistive technology. She is a technologist by trade and has 12 plus years of experience working in finance and investment banking domain. She champions technology, innovation and collaboration within her organization. Since her engineering days, she has keen interest to leverage technology to build cost-effective and robust solutions. Today, she explores how assistive technology meets force in her lightning talk. And Snehal, please come on stage. Over to you.
Right. Good morning, everyone. My name is Snehal Chaitanya. I work for ANZ. It's a bank. Today, I'm going to talk about how open source software meets assistive technology. Now, let's start with what exactly does assistive technology mean? Now, assistive technology is any piece of hardware or software, a product, a device, or a service which is used to enhance the abilities of a differently abled person. It is used to assist a person with special needs. So anything from braille to hearing aids to crutches to wheelchairs to something more high-tech like robotic arms or let's say eye gaze tracing software, all of it falls under assistive technology. So let's see how technology helps. First, we take a look at some numbers. Almost 15% of the world's population, which is more than 1 billion people, are either severely or partially disabled. Now, what does that mean? The opportunities that they have are limited, irrespective of the countries that they come from. So, technology can help bring down these opportunities. And how can technology help? Well, they can lower the barriers that these people encounter in everyday lives, doing everyday tasks like seeing, hearing, or even mobility. They can act more independently with the aid of technology. They can participate and enjoy the digital society better with the aid of technology. And of course, they should have the same access to information as rest of us. So these are some of the problems that technology can solve for the differently abled. Now, when I think of assistive technology, for me a very classic example is Professor Stephen Hawking. I'm sure many of you must have heard of him. I think all of you must have heard of him. So as we know, Professor Hawking has ALS, which means he cannot speak, he cannot move from his chair. Let's take a look at the video when the chair first came into picture in the very early days.
An answering system, actually, to convert the written text into synthesized speech. I mean, the voice sounds a little bit robotic, but should we give it a try?
Great.
Here's the clicker.
Right hand.
Welcome to the future.
My name is Stephen Hawking.
It's American.
Is that a problem?
Well, is that a problem? His accent is American. This is where we take a look at customization. Dr. Hawking, as we know, is British. Why should his synthetic voice have an American accent? Now, this is one of the challenges that proprietary devices or niche technology that is developed for special purposes has. It's not very easy to customize it. It lacks the flexibility. These products are not manufactured off the shelf. They are not mass manufactured or mass produced, which means the hardware or software that is available for this is either dated or very expensive. It is not very easy to support or maintain it either. So these are the key questions that assistive technology or any technology in general faces. Can it be customized? Can it be supported? Is it affordable? And is it easily available? This is where open source comes into picture. We all know what is open source software. It is a software that can be used and modified as desired. The licenses are freely available. FOSS is shared and distributed openly, so it is affordable as well and available as well. And we have communities across the world developing softwares and maintaining it. So looks like open source can answer some of the questions that assistive technology throws at us. So does assistive technology leverage open source in any way? So let's take a look where assistive technology meets open source. We'll come back to Dr. Hawking's chair here now. As we know, Dr. Hawking lost his ability to speak or to write in 1985. In 1988, he got his first synthetic voice, which was called Perfect Paul. It was only in 1997 that Intel offered to install its own computer as the processor for the chair, and they have been enhancing it ever since. Now, in 2008, Professor Hawking couldn't use the hand clicker anymore given his condition. Intel had to take the whole system back to their labs. And they tried putting a lot of state-of-art technology like eye gaze tracing softwares, facial gesture recognition, or even brain and human interfacing. But none of this actually worked given his condition or his preference. It was in 2013 that Intel came out with 3 solutions. They had one infrared sensor which was fitted to his glasses, which detected the cheek motion or the cheek muscle movement of his face. It also gave him a system to navigate this without using his hands. And of course, there was the speech processor. In 2015, Intel has made all of this as open source. Now, why would Intel do that? The reason Intel gives is a lot more technological innovation and improvement can happen with these softwares. And to make it happen, more people should be able to access it. More people should be able to use it, innovate with it, and build on top of it. So this is the basic philosophy of open source. If Intel is doing it, let's look at if any other industry majors are doing it. I have chosen a specific stream under artificial intelligence, which is deep learning or machine learning, because these are the foundation libraries for assistive technology normally. And we see all the major players here. We see Microsoft, we see Google, Facebook, Amazon. So what has Microsoft brought out? They have their cognitive network, which is a computational library, which they started primarily for speech and image recognition. We have Google with its TensorFlow library, which is again a complex algorithm used for training the artificial neural networks. We have FAIR, which is Facebook's artificial intelligence research, throwing up Torch as the open source library. It is available on GitHub. And we have a new player in Amazon. Now, Amazon's destiny is a product recommendation software, but they have still preferred to make it open source. And the reason they give is they want innovators to explore beyond speech and image recognition and use the same technology for some other diverse spectrum of industries. So what we see here is an emerging trend in all the industries to throw their research open to everybody so more people can innovate and more people can benefit. Now this is the power of open source. What is the way forward? The way forward, as we saw, is we have almost 1 in every 7 disabled, 15% of the world's population. On the other hand, there's good news that 50% of the world's population has access to internet. So 50% of the population can actually have access to technology. Add to it the rising trend in organizations towards diversity and inclusion. Not only are industries and organizations trying to bring the workforce into the mainstream, technological industry is trying to bring technology into the mainstream as well. It is not limited to the lab anymore. So where do we go from here? Let's take a beautiful example of what Google.org recently did. All this diversity and inclusion, open source, reaching people, all of this is coming together in this example. Google.org gave away a grant of $20 million to non-profits who are working only with open source technology to make a difference for the differently abled. Let's see a few examples. Perkins School for Blind, what did they do? Navigation accuracy of a GPS is about 30 feet. Now for an able person, it serves all right. But for a visually impaired person, 30 feet is still a large distance to cover. And it is very frustrating when you come near a building, but you don't know where's the entrance, you don't know where's the reception, you don't know where's the lift lobby. Now Blindways is an app which uses crowdsourcing so that able-bodied people can feed in clues, visual clues of how to navigate a way, and visually impaired people can use the same app to navigate better. It reduces the accuracy to up to 6 feet, which is the standard length of a white cane. Somewhere closer to home, we have Ratnanidhi Charitable Trust. They are very effectively using 3D scanning and printing with the help of IIT Bombay. They have used open source technology and come up with a low-cost scanner, which they use to take measurements for prosthetic limbs. These measurements are much more accurate, they are much more faster because of the technology available. They can be given to 3D printer manufacturers, which can then print 3D prosthetic sockets and then give it back to the rural areas where they are required. The whole process is now much faster, cheaper and better thanks to technology. One last example is Center for Discovery. Navigating wheelchairs manually is a difficult task, not only for the user but also for the carer who pushes that wheelchair. Center for Discovery has come up with a power add-on which can be fitted to any make or model of a manual wheelchair, and then it can be motorized at no time, which solves the mobility problem immensely. So what do we see here? We see niche research coming into mainstream through the powerful channel of open source. So I urge all of you to actually check out all the open source libraries that are available and probably tinker around, play with them and see how it can be used for better purposes. So a better world is where technology can work for everyone. As technologists, the onus is on us to recognize the potential of open source and use it in the best possible way. Now, I know some of you might come up with questions like open source is not the answer for everything. I agree. It comes with its own set of challenges like security or accountability, but we have to find a way to work around it. In today's world, we have robotics. You can check out ROS, which is the open source operating system for robotics. You can check out OpenAI, which is open source for artificial intelligence research. And then we have 3D printing, VR. All these technologies are everyday technologies now. They're not limited to labs. I leave you with one more video, the last video, where we demonstrate how existing research is being leveraged to come up with innovative assistive technology solutions. This is a glimpse into the future, and it is soon becoming a reality. Thank you. I'll take questions after this. I'm sure many of you must have seen this.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Thank you very much. Thank you very much.
Thank you, everyone, for listening through the lightning talks and getting enlightened.